If you are watching this video, that means you have already watched the previous video on the similar problem. We have been given a system like this, and we have been asked in that problem that what is the force required on this block of small mass m such that the system is in equilibrium, and what if I apply the double the force, then what will be the accelerations of both the blocks, right? Now in this next question, there is a change that this whole system is kept inside an elevator, and this elevator is going down with an acceleration a which is less than g. Now we have to do the same exercise again, that is we have to find out the capital F force and the acceleration of both the blocks if two times that force is applied. So let's do that question over here. So if I do the same thing again, okay, so let me draw the free body diagram of small m. The small m free body diagram will be like this. There will be rightward direction tension because you are pulling this towards left, right? So that will be capital F towards left, there will be T towards right, and mg force will be downwards, and then there will be a normal reaction upwards, that is capital N. Now once you start pulling it towards left, there will be a friction between both the blocks, and as a result the frictional force will act toward right direction. So here there will be a frictional force mu times N. Okay, the mu is the coefficient of friction between the two blocks. Between this capital M and the floor, the mu is 0, and between these two blocks there is a frictional coefficient, that is mu. Okay, and now there is another force because of the accelerated frame of reference. So if you know already that the accelerated frame of reference, when you are in accelerated frame of reference, there will be a pseudo force in the direction opposite to that of the acceleration of the system. That means the pseudo force on this block will be small m times a upwards. Since the elevator is going downwards, it will be upwards. So here we have the equations then. N plus ma is equal to small mg, and then here we have T plus mu n is equal to F, capital F. Okay, so these are the two equations that you get. Now you have to find out capital F, right? So these are the two equations that you have got, right? Now let's do the same exercise with the capital M mass, right? So let's do that. So what are the forces on capital M mass? You can see from this diagram, since the mass small m is experiencing upward force of capital N on capital M mass. So let me draw it here so you can see the diagram as well. So the downward force is capital N. Because of the Newton's third law, the small m will also exert the same force on capital M, which is downwards. Okay, obviously there is a mg component over here, mg force over here, and upward force of normal reaction and dash. This normal reaction is between the capital M and the floor. Okay, so that you have got already. And now what else is there? Did we miss anything? Yes, we have of course missed the pseudo force, right? So that is capital M into A. The pseudo force is in the upward direction. Okay, these are the vertical forces. I hope there are no more forces left. So capital Mg is here, N is here, N dash is here, Ma is also there. Okay, and now then there is a tension in this direction, capital T, and now that tension will be counterbalanced by the frictional force between these two blocks M and capital M, right? Because the force on the smaller block is towards right, the frictional force is towards right, the friction that will be experienced by the capital M block will be towards left, because when the two bodies are moving on the surfaces of each other, the four frictional forces are opposite in direction, right? If you rub two bodies on each other like this, if it is if this body is experiencing force friction here in the left direction, this body will experience force in the opposite direction, right? So here the frictional force for the capital M will be opposite to that of small m. That means it will be towards left, that is mu into n. So we got one more equation, T is equal to mu n, right? Now there is no need of this vertical forces here, but it helps to solve another type of problems. Maybe it is not asked in this problem, but it may help you in another problems, right? So that's why it is better to write this as well. Okay, so now we have T equal to mu n. So now F will become 2 times mu n. I just substituted T equal to mu n in this second equation. Now what is n? So n can be found out from the first equation. You can see from here n is mg minus ma. So this is mg minus ma. So this is the force which is required in this case, in this new case, so that this whole system is in equilibrium. Okay, so let's go to the next case, right? So let me copy the diagram over here. This is the diagram. Let me put it here. Now what we have to do in this second part is that we have to find out the acceleration of both the blocks such that this whole system is moving down with an acceleration a which is less than g, because it is kept in a elevator of accelerating a, it is going downwards, right? So now let me draw the free body diagram again. So for small m, let me draw it over here. By the way, if I push this block with double the force, right? So now this is the second case where we have to find out the acceleration of the both blocks. If I apply the 2F force, that is double the force, right? So that means the acceleration of both M and capital M has to be found out, right? But you can see from here that accelerations will be equal because they are connected by a same string. Okay, this is a inextensible string. That means both the blocks will have the same acceleration. Okay, so it is sufficient for us to find the acceleration of one block only. So let's do that. So this is small m mass over here. This is 2F force applied. Okay, double the force. The tension is towards right. Very good. And the normal reaction is upward, that is capital N. The downwards is mg. The pseudo force is ma. Okay, we have already seen these vertical forces, how they are acting. And what else you can see from here? You can yeah, so that is pretty much all the forces summed up over here, right? So there is no other forces as far as I know. Okay, so now from here we can see 2F minus T. Okay, there is a friction as well, right? The friction between these two blocks, that is mu. So here there will be mu times n. So 2F minus T minus mu n. Let's say this is n. Okay, let me draw properly. Mu n is equal to small m times a. This is my first equation. Okay, now let's see what happens with the capital M. So if I draw it over here, capital M mass, the rightward direction tension is towards right. Okay, that is obvious. Now the friction between these two is 0 because the frictional coefficient is 0, but the friction will be experienced by capital M by the force which is on force the capital M will experience the friction because of the block kept on its head, right? Now I already told you that if small m will experience a force, frictional force towards right direction, capital M will be experiencing force towards left direction. So this will be towards left, the same magnitude mu n. So here it will be T minus mu n is equal to capital M into A. Obviously it will go towards right, right? If it is going towards left, the downward block will go towards right. Now let's find out the acceleration. How will you do that? You just add this. So here we have 2F minus 2 mu n is equal to m plus capital M into A. So 2F is 2 times, what was the F that we have got in the previous case? 2 mu times mg minus ma. So let's remember this, 2 mu times mg minus ma. So let's write it over here. 2 mu times mg minus ma minus 2 mu times n is equal to m plus m into a. But what is the n value? Okay, what is the n value? From here you can see again the same thing. N plus small ma is equal to mg. N plus small ma is equal to mg. So n is equal to mg minus ma. So I will put that directly, mg minus ma. So this will become 4 mu times mg minus ma minus 2 mu mg minus ma. This is equal to small m plus capital M into acceleration a. Now this will become 2 mu times mg minus ma divided by small m plus capital M. This is equal to the acceleration a in the second case, and both the blocks will have the same acceleration.